This presentation is about steel pre-engineering systems. Pre-engineering systems are systems that are already calculated like trusses, and in our particular case, is about open web joists. Open web joists are elements that are very good to be used when we have long spans and the loads are not that big. In this presentation, we will study this particular open web joist and the characteristics, advantage, and limitations of this structural system, and also the concept of steel desk. Steel members have denominations. Usually they are prefabricated and they will support specific loads and are made for specific spans. Well, depending the span and the load, we will use a different material. Usually when we have this kind of elements, we have a denomination. Denomination is like the name that this material will have. For example, a W12 by 26 is a beam that is W is like similar to a square. We have a lot of material in the top part and in the bottom part, because as you know, when we have a beam and we put a weight in the top part, this beam will tend to deform in this way, and we have compression in the top areas and tension in the bottom areas. I mean, the fibers here will extend and the fiber here will compress. In the middle, we have a section where nothing happens. Well, that is the reason why it's convenient to use this kind of materials. Well, an open web joist is something similar to it. And it works a little bit like a truss, where we can just have elements that are heavier in the top and bottom areas, and a web area where you have less material in the center. Well, these kind of joists are very convenient when we have a relatively light and uniform floor or roof loads. This material is composed by three parts. We will have a top chord, we will have an inferior chord, and we will have a web member. This is the top, this is the bottom, and there is a member that will put them together similar to a truss. Usually there is a thickness material in the top and the bottom, and the web member is not as heavy as the other two members. Open web joists are prefabricated. They are lightweight. They are similar to trusses, and they are designed according with what is called a series. There are series of joists that are called J and K. The difference between J and K is that one is supporting more weights, but the span goes up to 56 feet. It's short span. LJ and LH member, or L series, span to 96 feet, and DLJ and DLH series span to 144 deep. Students must learn and memorize these numbers, because in the moment that you are doing a project in your design studios, you can just go to the tables and decide that what type of elements you need, and you will have all the dimensions. Well, the designation of this particular joist are as follows. You will have a number, you will have a letter, and you will have a second number. For example, a designation 12K4 means 12 is the deep in inches of this particular material. If we imagine that the material is made with two members, like L members, like double angle, like this kind of members, where we have two in each side, and we have a web there together, where we will have here the members, and we'll have the web going around. 12 will be the deep of this material, this deep. K is the joist series, I mean, how much span can support. In our case is maximum 56, and 4 is the designation with the series. I mean, this material will have a thickness, and depending how thick the material is, you will have a designation in the series. The higher is the number, the heavier is the joist. Web joists are commonly referred as a bar joist because they were made with bars in the earlier construction. And the modern joist, instead, they use flanges and web configuration with angles, as you can look in this example. Also, those joists, because they are tall, as you can look, we have an element here, and we have the web member that is going there, and we have the other element. They are in section quite tall, and the width is relatively short. Therefore, they will tend to move and rotate in these directions depending the loads. Well, in order to eliminate that possibility, you can have a connection with the next joist and have more stability. Well, it will be more difficult that this element will rotate when you have a connection, and that kind of connections are what is called bridging. That is something very important for this type of material. Web members can also be just bars, and we can look here, and the space between them can be from 2 feet to 6 feet, depending on the magnitude of the load, the capacity of the deck that usually is made out in steel, and the span. However, web joists have limitations, and the main one is that they are designed to work as a simple support beam. I mean, they will support uniformly distributed loads. We studied in the past several types of beams, and we did a diagram of moments and shear when we have forces that are not uniformly distributed, and that is not convenient for this kind of elements. Well, it be convenient that you have a distributed load. That means that you are not supposed to hang big weights in the top of this particular material. For example, if I want to hang from a web joist that is like this, I want to hang something there, a weight, that will not be convenient. If we want to put a specific weight, like imagine a water tank in this particular area, that will not be convenient. It's used and designed for a uniform distribute loads. The properties of this material is that allow large spans with small sections, is wonderful for building heights combined with low depth. Is very good when we use it because you will have openings and you can install service. For example, if we have a concrete beam and we open a hole, we are reducing this particular thickness from the beam. It will be like all this area in the beam is lost because we have a hole in the middle of it. Well, only the top section here and bottom section will be working. But when we have these kind of elements that are like trusses, we have holes and we can install pipes and services without any problem. And that is something very convenient for this type of material. Some information about this material is prefabricated, similar to trusses. They support floor and roof systems, and normally the systems are metal decking, light load, open spaces, and they are very popular in warehouses. Places like Walmart's or some clubs where you have big spans and we have a roof that is lightweight, use this type of material. It's very efficient. The first joist was designed in 1923. It was a Warren truss configuration made with bars and was called a bar joist. Thereafter, in 1928, the Steel Joist Institute was formed, and they decided to standardize this kind of elements, and they published the standard joist types like K-series, K-series, LH-series, and DLH-series that are normal spans, long spans, or deep long spans, as we can look here. We assume that this material is being connected and that there is some kind of bracing between the floor and deck against the lateral buckling. That is what I explained that happens when you use some bridging between them. The Steel Joints Institute requires web members to be symmetric with the center line of the joist. They are like beam columns. And the idea is that we have a material that will allow to have symmetry that will reduce the effect of bending stress when we have eccentric loads. Usually the cords are made with a steel of 50 KSI and the waves can be 50 or 36. We have tables that will tell us the type of joist that we have, and the selection is based on several assumptions, and you have more information in page 81 of the textbook. The maximum lift load of this deflection is 360. I mean, the length of this material, for example, when we have a weight, this material, like the web joist, will tend to have some deflection. What that means, it means that the material will in some way deform and will tend to move down a little bit like this. And this distance is the deflection. Well, the deflection will be maximum in most circumstances at 1/360 of the span. Well, if the span is 360, the element can move 1 inch, but also is accepted in some circumstances 240. If we have a span, for example, of 240, the deflection will be 1 inch. All the loads, dead and live, need to be uniform, and no joist can be used for a span that is exceeding 24 times the deep. I mean, the deep cannot be bigger than 24, the span cannot be bigger than 24 times the deep of this particular material. Let me clean this. And the joist tables will not provide any loading condition other than uniform, unfortunately. Well, we need to think that we have uniform conditions, and if that is not the case, calculations will change and will be a little bit different. All the analysis of this element is made similar to trusses. You will have vectors and will be calculated usually using trigonometry like truss analysis, and the design capacity will depend on the type of connection and the steel strength. And it's very important to understand how bridging will make this material more resistant to the loads. Bridging is the possibility to allow these members to have some lateral stability, as I explained before, and will depend on the slenderness radius. Well, the bridging, let me go back, the bridging not necessarily will be a bridging that is uniform, like horizontal, from top member to bottom member. Bridging also could be something that allow the material to connect the top member with a bottom member and this top member with the bottom member, and they can be united in the center, and that will create a system that is much more stable, what is something important in this particular material. There are some accessories like end anchorage beams that will allow us to have some welding between the beams and those elements, stabilizer plates that will allow this material to don't move and rotate so much. We have some tables here, and you have more information in the book about them. And usually this material is combined with a floor or roof system that can be metal decking. The metal decking can be the one that we studied before, where we have this metal and steel in the top, and concrete for floor system. But when we speak about a roof system, because nobody will be walking the top of this material, usually what happens is that we will have the decking in steel, and we'll have some materials to protect and allow to have some protection because of the heat. And finally, we will have a roof system in the top that will allow the evacuation of the water. And that will be a very simple system that is used in many warehouses where nobody will be walking in the roof. But also can be made composite decks with ribs and cast in place concrete that we already studied in the past, as you can look in this particular open web joist and metal deck construction. More reading material you will find in the Underwood and CUNY book chapter 5. This concludes this presentation.